The problem with our order class is that it has a lot of hidden dependencies. It's depending on mail message, SMTP client, the inventory system, the payment gateway, a logger, and datetime.now. And the result is that we have a class that has very tight coupling. There's no easy way to change any of these implementation details, so this is an open-closed principle violation. The only way we can change how order works is to go in and actually change its code. And it all ends up being very difficult to test. So let's talk about a particular technique that we can use to make this easier. Dependency injection is a technique that's used to allow calling code to inject the dependencies that a class needs when it is instantiated. This also goes by the term of the Hollywood principle, which is basically, don't call us, we'll call you. So instead of our class calling SMTP client, it could say that it needs some kind of a notification service that knows how to do notification, and it will go ahead and call that, but it doesn't need to instantiate it itself. Now, the term dependency injection, or DI, has three primary techniques that I want to talk about here. The first one is constructor injection. The second is property injection, or setter injection. And the third one is parameter injection. There are other methods that exist both for dependency injection as well as to solve the general problem of the dependencies that exist when a class knows about the things that it's newing up. One of those is called service location, but those are beyond the scope of this particular module. So the first type of dependency injection is called constructor injection, and this is an instance of the strategy pattern, which is a very popular design pattern. It's extremely useful in object-oriented programming. With constructor injection, dependencies are passed in via the constructor. The constructor then is being honest with the things that call it, in that it is explicitly stating the things that it needs in order for it to be in a valid state and to be able to do the work that it expects to be able to do. The pros of this approach are that classes self-document what they need. It works well with or without a container, and I'll talk more about containers in a moment. And classes are always in a valid state once constructed. Some of the cons are that constructors can end up with a great many parameters if they have a lot of dependencies, which is a design smell in and of itself that needs to be addressed. Also, some features, for example, serialization, may require a default constructor, for example, a parameterless constructor. So even though you may have a constructor that explicitly specifies all of the things that your class depends on, for reasons like the need to use serialization, you may also still have to expose a parameterless constructor that doesn't have those things set up. Also, some methods in the class may not require things that other methods require. So placing those dependencies into the constructor effectively makes all of the methods require all of the dependencies. This is also a design smell because if you have methods in your class that don't require certain things and other methods that do, it's likely telling you that your class lacks cohesion, and it would be wise for you to refactor it into multiple classes that share dependencies and share, common tasks. Another type of injection is property injection, which is also known as setter injection because you set the thing that you're injecting using the set method on the property. Some of the pros are that the dependency can be changed at any time during the object lifetime, and thus this is very flexible. However, one of the cons is that objects are in an invalid state between construction and the setting of dependencies via setters, unless the constructor calls the setters. And it also can be less intuitive because there isn't any one place that you can go on that class, short of reading the documentation, that tells you exactly the properties that need to be set and perhaps the order of setting those properties in order for the class to ultimately be usable by the client calling code. And then the third method is through parameter injection. In this case, the dependencies are simply passed in as a parameter to the method. This is the most granular and it's very flexible. It does not require any changes to the rest of the class. However, some of the cons are that this breaks the method's signature. So if you have a method that's already in use by a great many classes in your application, some of which perhaps you cannot easily change, then breaking that method signature could be very expensive. Whereas adding another constructor that allows you to pass in this dependency might be something that you can easily do without breaking any of the existing code that depends on that method. Similar to with constructor injection, this can result in having many parameters on your method. But again, this is a design smell in and of itself and something that you should address in order to create a more cohesive design. You should consider using parameter injection primarily if you only have one method in a particular class that has a certain dependency. Otherwise, it's better, in my opinion, to use constructor injection because this is able to make it very explicit to anyone using your code what exactly it needs in order to function.